dear students, today's topic is cube roots of perfect cube numbers. We will be using same method to learn cube roots of perfect cube numbers which we have already discussed in the topic of square roots of perfect square numbers. The method is ladder method. Let's get started. But first of all, let's understand what is meant by cube of a number. When we multiply a number by itself 3 times, it means we have cubed the number. For example, 3 cube means 3 times 3 times 3, which is 27. 27 has 27 cubes of 1 units in it. Now, can you tell me what a cube root is? Cube root is just opposite of the cube. We know that 27 is the cube of 3 and 3 is the cube root of 27. The symbol of cube root is similar to the symbol of square root with just one addition of 3 on it. Before understanding the ladder method to find the cube root of perfect cube number, let us understand about perfect cube number. We can say that perfect cubes are the numbers which have exact factors. Now, what are the factors? Factors are the numbers we can multiply to get another number. For example, 2 and 3 are the factors of 6. 4 and 3 are the factors of 12. 2, 2 and 3 are also the factors of 12. Now, for example, we have to find out whether 216 is a perfect cube or not. For this, we have to search for a number which can be multiplied by itself 3 times to give 216. 6 multiplied by itself 3 times gives 216. Therefore, 216 is a perfect cube number because 6 is the exact number of factors. But is 217 a perfect cube? No, because it does not have exact factors which can be multiplied by itself 3 times to give 270. There are few more examples of perfect cube numbers and non-perfect cube numbers. I am going to provide you a table with perfect cube numbers and non-perfect cube numbers. You can see that the numbers on the right hand side of this table does not have exactly same number of factors to give the number. But on the left hand side of this table, all the numbers are perfect cube numbers. Let us take an example to calculate cube root of perfect cube number, say 250,047 by ladder method. Let's draw the ladder and write the number 250,047 on the top of the ladder. On the left side of the steps of the ladder, we will write the smallest prime number that can exactly divide the number 250,047. The smallest prime number that exactly divides 250,047 is 3. We will write 3 to the left side of the number on the ladder and divide 250,047 by 3 to get 83,349. Write this number on the bottom step of the ladder. This number is again divisible by 3. We will write 3 on the left side of this number and divide 83,349 by 3 to get 27,783. Put this number at the next bottom step of the ladder. 27,783 is again divisible by 3. After dividing 27,783 by 3, we get 9,261. Put 9,261 at the next bottom step of the ladder. which is the smallest prime number that exactly divides 9261. Again, it is 3. Write 3 on the left side of the ladder and divide this number by 3. We will get 3087. Again, write 3087 at the next bottom step and divide it by prime number 3. We'll get 1029. 1029 is divisible by prime number 3, and after dividing 1029 by 3, we get 343. Write 343 at the next bottom step of the ladder. 343 is not divisible by 3. Here, we need to find the smallest prime number that exactly divides 343. 7 can divide 343 exactly and gives 49. We will write 49 at the next bottom step and 7 to the left of 343 on the ladder. 49 is divisible by 7 again and gives 7. Write 7 below 49 on the next bottom step of the ladder and 7, which is the divisor, to the left of 49. Lastly, we will divide 7 by 7 and get 1. You can extend your ladder until you reach 1. Now we have got 1, so our ladder is complete here. We will write down all the numbers we get on the left side of the ladder. These numbers are 3 times 3 times 3 times 3 times 3 times 3 times 7 times 7 times 7. We will join 3 numbers at a time to get sets to find cube root. First 3 numbers make first set. Next 3 numbers make second set. Last 3 numbers make third set. We will take one number from each set. 3 from first set, 3 from second set, 7 from third set. Then multiply 3 times 3 times 7, we get 63. Therefore, 63 is the cube root of 250,047. Let us take one more example and find the cube root of 39,304. First of all, we set up our ladder and write 39,304 at the top of the ladder. We need to find the smallest prime number that exactly divides 39,304. As we observe that 2 is the smallest prime number that exactly divides the given number to give 19,652. Write 19,652 on the next bottom step and 2 on the left. Again, 19,652 is divisible by 2 and gives 9,826. Write 9,826 at the next bottom step of the ladder and 2 to the left of 19,652 on the ladder. 9,826 is divisible by 2 again and it gives 4,913. Write 4,913 after dividing 9,826 by 2. Write 4,913 at the next bottom step of the ladder. 4,913 is not divisible by 2, 3, 5, 7, 11, 13, but it is divisible by 17. So 17 is the smallest prime number which can exactly divide 4,913. Therefore, 17 is the best number to choose. Write 17 to the left of 4,913 on the ladder and do the division. We get 289. And continuing in this manner, we will reach at 1 after dividing 289 by 17 and again 17 by 17. Our ladder is complete here because we have reached at 1. Write the numbers we got on the left of the ladder. These numbers are 2, 2, 2, 17, 17 and 17. We will make sets by taking 3 numbers at a time. In this case, we will get two sets. From the first set, we will take the number 2. From the second set, we will take the number 17. Multiply 2 by 17, which will give 34. Therefore, 34 is the cube root of 39,304. Isn't the ladder method of finding cube roots of perfect cube numbers easy and interesting? I hope you all have understood this method of finding cube roots of perfect cube numbers. I'm going to give you few questions for practice. Your first question is, what is the cube root of 238,328? Your second question is, this question is a bit tricky one. The question is, boxes of candies are kept in a cubical carton. If the total number of boxes in the cubical carton are 32,768, find the number of rows in each layer. I'm going to give you a hint. You need to find the cube root of the given number. The answers to these questions will be given to you once you solve the cube roots of these two numbers.